bonding. So our main focus in this video will be on bonding. Our main focus, we are going to focus much on bonding. So we are going to start by, okay, so according to our syllabus here, we have bonding. We need to describe the compound. We need to describe the formation of ions. Okay, we also need to describe the formation of ionic bonds. The formation of ionic bonds. So let us describe electron shells. So what are electron shells? So electron shells are energy levels. Electron shells are energy levels. So electrons rotate or orbit the nucleus of an atom in layers called shells. By the way, the shells are also called layers or energy levels. So electrons orbit the nucleus or move around the nucleus in layers called shells. So these shells are labeled as K, L, M, N, etc., starting from the one closest to the nucleus. So let us illustrate what we are talking about here. So we have the nucleus, and this nucleus is surrounded by shells. We have the first shell, we have the second shell, we have the fourth shell. So the first shell is labeled as K. The second shell is labeled as L. The third shell is labeled as M. The fourth shell is labeled as N. Okay, so these are the first four shells. So the next thing that we are going to look at, electronic configuration. Okay, so what are electronic configuration? So electronic configuration is the arrangement of the electrons in the energy levels or in the shells. The arrangement of electrons in the shells or in the energy levels or in the layers is called electronic configuration. Let us demonstrate what we are talking about. So we have the nucleus, and this nucleus is surrounded by two shells, and it is showing the arrangement of particles. So as we can see the arrangement of electrons. So the whole arrangement of electrons is called electronic configuration. Okay, so as we can see, we have successfully managed to describe electronic configuration. So the next thing that we are going to look at how many electrons are supposed to be in a given shell. So the maximum electrons per shell. So each shell can hold a maximum number of electrons determined by the formula. So this is the formula that we'll be using. Determined by the formula 2n to the power 2, where n is the shell number. Okay, so for example, the first shell, where there is n, we are going to write 1. So if we say 1 to the power 2 is equal to 1, 1 times 2 is equal to 2. So the first shell will have two electrons according to our formula. Okay, according to our formula, the first shell will have two electrons. Let us also look at the second shell. So where there is n, we are going to write 2. So n will be substituted by, or n will be replaced by 2. So if we say 2 to the power 2 is equal to 4, 4 times 2 is equal to 8. So the second shell will accommodate 8 electrons. The second shell will accommodate 8 electrons as stated here. Let us also look at the third shell. So we are also going to apply the same formula. So where there is n, we are going to write 3. So 3 to the power 2 is equal to 9. 9 times 2 is equal to 18. So the third shell, or third energy level, will accommodate 18 electrons. Okay, will accommodate 18 electrons. Let us move to the fourth shell. So the fourth shell, we are going to apply the same formula. Where there is n, we are going to write 4. 4 to the power 2 is equal to 16. 16 times 2 is equal to 32. So we have 32 here. So the fourth shell will accommodate 32 electrons, or the fourth shell will possess or will have 32 electrons. So this is how we can know the maximum number of electrons per shell of the energy level. So the next thing that we are going to look at, we are going to look at the filling order. So what order do we need to follow when filling up the shells? So electrons fill the shells in a specific order based on their energy. The shells closer to the nucleus are filled first because they have lower energy. Okay. So filling up of shells depends on the energy. So the shells closer to the nucleus are filled up first because they have lower energy. Okay, so let us demonstrate what we are trying to put across here. So we have the nucleus, and the nucleus is surrounded by shells. We have the first shell, we have the second shell, we have the third shell, we have the fourth shell. Okay, so this shell, which is the shell that is close to the nucleus, has a low energy level or low energy. So therefore, this one is close to the nucleus, as stated here. The shells close to the nucleus are filled first because they have lower energy. Okay, so we labeled these shells. The first shell is K, the second shell is L, the third shell is M, and the fourth shell is N. Okay, so we have a question here. Write and draw the electronic configuration of the following nuclides. Number 1, lithium. Number 2, sodium. Number 3, beryllium. Number 4, carbon. Number 5, chlorine. Okay, so we are asked to write and draw the electronic configuration. So the proton number of lithium is 3. So let us come up with the electronic configuration. So our electronic configuration will look like this. 3 is equal to 2, 1, 2, 1. So the outermost shell will have 1 electron. Let us come up with the electronic structure. So we have the nucleus, this nucleus is surrounded by two shells, the first shell and the second shell. So according to our electronic configuration here, the first two electrons will be accommodated in the first shell. Okay, then the last one electron will be accommodated in the last shell, as we can see here. So we have successfully managed to come up with the electronic configuration and the electronic structure, which is here. Okay, the electronic structure, which is here. We move to the next nuclides. The next nuclide or the next element that we have is sodium. So the proton number of sodium is 11. So let us come up with the electronic configuration. So electronic configuration is equal to 281. So we draw the electronic structure. We have the nucleus here, and this nucleus is surrounded by three shells. Surrounded by three shells. So the first two electrons will go to the first shell. Then the second 8 electrons will be accommodated in the second shell, as we can see in the second shell. Then the last 1 electron in the outermost shell or in the last shell. So as we can see, we have successfully managed to come up with the electronic configuration and the electronic structure, or we have written the electronic configuration and we have drawn the electronic configuration. Okay, let us move to the next element or the next nuclide. We have beryllium. So the proton number or the number of electrons here is 4. So we are going to say 4 is equal to 222. Okay, so we have the shell, we have the nucleus, and this nucleus is surrounded by two shells, the first shell and the second shell. So the first shell will have 2 electrons. The outermost shell will have 2 electrons also. So as we can see, we have written the electronic configuration. We have also drawn the electronic configuration. Let us move to the next nuclide. We have carbon, and we can see the number of electrons here is 6. So 6, we are going to say 6 is equal to 2 to 4. 2 to 4. So the first thing that we are going to do is to draw the nucleus. We have the nucleus here, and this nucleus is surrounded by two shells. The first shell, the second shell. Okay, so the first 2 electrons will be accommodated in the first shell. Then the last 4 electrons in the outermost shell or in the last shell. Okay, so we have written the electronic configuration. We have also drawn the electronic configuration. Let us move to the last element. The last element, we have chlorine here, and we can see the number of electrons is 11. The number of electrons is 17. By the way, we need to remember that proton number is equal to electron number. So since we have 17 as our proton number, we need to remember that we also have 17 as our electron number. So therefore, we are going to say 17 is equal to 287. So we are going to draw our 3 shells. So we have the nucleus, and this nucleus is surrounded by 3 shells. So the first two electrons will be accommodated in the first shell. Okay. Then the second 8 electrons in the second shell. In the second shell, as we can see here, in the second shell. Then the last 7 electrons in the last shell, or in the outermost shell, or in the outermost energy level. So as we can see, we have 7 electrons in the outermost shell. Okay, so we are done with our question. Let us proceed. The next subtopic that we are going to look at, ions. So what are ions? So we need to remember that ions are atoms or groups of atoms that have a charge because they have lost or gained electrons. Okay. Ions are atoms or groups of atoms that have a charge because they have lost or gained electrons. How ions form? So ions form by losing electrons. So if an atom loses electrons, it becomes a positive ion, also known as cation ion. For example, sodium becomes sodium cation. Okay, sodium becomes sodium cation. This one being it has lost one electron. So let us illustrate what we are talking about here. We have sodium, and it is surrounded by 3 shells. 3 shells. The first shell has 2 electrons. The second shell has 8 electrons. The the outermost shell has 1 electron. So after losing this 1 electron, sodium will have a positive charge, as illustrated here. Sodium will have a positive charge, and the sodium will have 8 electrons in the outermost shell. This one being it has lost 1 electron in the outermost shell. Okay, so this is one of the way ions can be formed. Let us look at the second way, by gaining electrons. So if an atom gains electron or electrons, it becomes negative charge, also known as negative anion. Okay, so for example, we have chlorine. So chlorine becomes chlorine anion, or chlorine will have the negative charge. This one being it has gained 1 electron. Let us demonstrate. So we have chlorine here. Chlorine has 3 shells, 2 electrons in the first shell, 8 electrons in the second shell, as illustrated here. Then 7 electrons in the outermost shell, or in the outermost energy level. Then after gaining 1 electron, chlorine will have a negative charge, or chlorine will become an ion. Okay, chlorine will become an ion. Chlorine will become an ion. Remember, chlorine had 7 electrons in the outermost shell. So after gaining 1 electron, chlorine has 8 electrons in the outermost shell. Okay, so ions can also form by gaining 1 or gaining electrons. Ions can form by gaining electrons. So the question that we are going to ask ourselves is, why do atoms become ions? Why do atoms become ions? So atoms becomes ions, or atoms forms ions to achieve full outer shell of electrons, which makes them more stable. So the reason why atoms become ions is to gain stability. So the whole essence of forming ions is to attain a stability. They do so that they become stable. Okay. So the next subtopic that we are going to look at, bonding. So like I said, our main focus in this video will be on bonding. Okay. So what is bonding? Bonding is a chemical combination of two or more atoms. Bonding is a chemical combination of two or more atoms. Chemical combination of two or more atoms. Okay. So we need to remember that there are three types of bonding. Number one, covalent bonding. Number two, ionic bonding. Number three, metallic bonding. So we are going to concentrate much on ionic bonding in this video. Then in the next video, we'll also look at covalent bonding. So let us start with the ionic bonding. So what comes into our mind whenever we hear the term ionic bonding? So ionic bonding is a type of chemical bond that forms when one atom transfers one or more of its electrons to another atom. Okay. So ionic bonding involves losing and gaining of electrons. So when we say one atom transfer one electron, we are simply saying one atom loses electron to another, one atom gains one or more electrons. So ionic bonding involves gaining and losing of electrons. Okay. For example, we have calcium and calcium chloride. Calcium chloride, CaCl2. So calcium has lost two electrons, and the two atoms of chlorine have gained two electrons coming from calcium. So here there is ionic bonding involving. We also have potassium oxide. We also have sodium chloride. Okay. The next thing that we are going to look at, the formation of ionic bond. How ionic bonds are formed. Formation of ionic bond. For example, we are going to look at formation of sodium chloride. Formation of sodium chloride. So sodium atom loses one electron in the outermost shell, from its outermost shell, to form sodium ion with a positive charge. Sodium atom loses one electron from the outermost shell to gain a positive charge. So initially, sodium has electronic configuration which is 281, Okay. Chlorine also gains one electron to its outermost shell to form chloride ion with negative charge. So initially, the electronic configuration of chlorine is 287. So let us illustrate. So we have the nucleus of sodium, and this one is surrounded by um, 3 shells. So 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the last shell. Okay, then here we have sodium. Sodium, we have chlorine. Chlorine is also surrounded by 3 shells, 2 electrons in the first shell, uh, 8 electrons in the second shell, and 7 electrons in the outermost shell, or in the last shell. So sodium will gain 1 electron, so that uh, it becomes negative anion. Okay, it becomes negative anion. So let us illustrate. So this one will lose this electron, and this electron will become will stay here. Okay, so it will lose this electron, and this electron will be located here. So let us demonstrate properly so that we understand better what we are talking about. So let us draw. We are going to draw. We have sodium, and this one is surrounded by 2 electrons. So after losing 1 electron, sodium is now surrounded by 2 shells. Okay, surrounded by 2 shells, and it has 8 electrons in the outermost shell. So like I said, elements form ions to gain stability. So we can see that this cation has 8 electrons in the outermost shell. So therefore, sodium has become stable. Let us also demonstrate um, the stability of chlorine. So chlorine had 7 electrons in the outermost shell. So after gaining 1 electron, chlorine is now having 8 electrons in the outermost shell. So we can see that chlorine is also stable. So no wonder we are saying elements becomes ions to gain stability. So we have seen that sodium has 8 electrons in the outermost shell. Chlorine has 8 electrons in the outermost shell. So these 2 ions have become stable. Okay, these 2 ions have become stable. Let us also come up with a new electron configuration. So we have seen that initially sodium had 281. So now here we have sodium ion. So sodium ion has 228. Let us also come up with the new electron configuration for iron chloride. So initially, chloride ion, chlorine had 287. So we can see that chloride ion has 288. So here we have 8 electrons in the outermost shell. Even here we have 8 electrons in the outermost shell. So therefore, these are capable of forming a compound. So we are now going to form a compound, and this compound will be called sodium chloride. So this is called sodium chloride. So we have seen the formation of ionic bonds. We have seen the formation of ionic bonds between sodium, which is a metal, and chlorine, a non-metal. So we have illustrated the formation of ionic compound. Now let us look at the physical properties of ionic compounds. The first physical property that we are going to look at is we need to remember that ionic compounds are made up of positively or negatively charged ions. So ionic compounds are made up of positively and negatively charged ions. Physical property number 2, they have high melting and boiling points because of strong electrostatic force of attraction between ions. Okay, so because they have strong force of attraction, high melting temperature or high melting temperature are needed to break down electrostatic force of attraction between ions. The next physical property that we are going to look at, ionic compounds are soluble in water but insoluble in organic solvents. The ionic compounds are soluble in water but insoluble in ionic solvents. So the organic solvents like ethanol and petrol. We also need to remember that in aqueous state or aqueous solution or molten state, ionic compounds are capable of conducting electricity because its ions or their ions are free to move. They are non-volatile. The last physical property, they are non-volatile and generally solids at room temperature. So these are physical properties of ionic compounds. So to appreciate the importance of what we have learned, let us extract some questions from past papers. So the first question is coming from 2019 paper 2, and the question is question B3. The diagrams below show atoms of sodium and chlorine. The first question, which is question B3A, question B3A, state the type of bond that exists in the compound formed when the two elements combine. So we have sodium and we have chlorine. Sodium is a metal and chlorine is a non-metal. So when a metal and a non-metal combine, they'll form an ionic compound, and the bond will be called ionic bond. So our answer here is the ionic bond. We move to the next question, which is question B, Roman numeral 1. Draw the structure of the compound formed when sodium and chlorine combine. We draw the structure of the compound formed. So here is the structure. We have this the structure of the stable sodium, and we also have the structure of the stable chlorine. So we have answered this question. Let us move to the next question, which is question B, Roman numeral 2. State the chemical formula for sodium chloride. So here is the chemical formula, NaCl. So we have answered this one. Let us move to the next question, which is question C. Explain in terms of bonding and the structure why sodium chloride has the following properties. C, Roman numeral 1, a very high melting point. So the reason why ionic compounds have high melting points, they have a strong electrostatic force of attraction between ions. So therefore, to break down these electronic forces of attraction, high melting temperature or high melting point is needed to break down the bond. The next question, which is question C, Roman numeral 2, high electrical conductivity when molten. So they do conduct the electricity in molten states or molten state because ions are free to move. Ions are free to move, therefore they are capable of conducting electricity. Let us also extract one question from 2012 past paper, and this paper is paper 3. And this question is question 4. The diagram below represents electronic arrangement of a particular atom. Start this diagram and answer the questions that follow. Okay, so we are given the electronic structure here. So we can see 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the outermost shell. Question 4a, the relative atomic mass of the atom represented is 23. What is its proton number? So if we check from the periodic table, an element with the mass number 23 is sodium. So here we are talking about sodium, and the atomic number of sodium is 11, or the proton number of sodium is 11. We move to the next question, which is question 4a, Roman numeral 2. What is the neutron number? So to find the neutron number, we are going to say neutron plus proton is equal to 23, or neutron plus proton is equal to mass number. Do we have the proton number? Yes, we have the proton number, which is 11. We collect the like terms. We are going to say 23 minus 11. We are going to get 12. So neutron number is equal to 12. Neutron number is equal to 12. We move to the next question, which is question B, Roman numeral 1. In which group of the periodic table is the element found? So sodium is found in group 1. Sodium is found in group 1. B, Roman numeral 2. Explain your answer in B, Roman numeral. In B, Roman numeral 1. So the reason why we have the reason why we are saying it is group 1, the given element has 1 electron in the outermost shell. So therefore, all elements from group 1 have 1 electron in the outermost shell. All elements from group 2 have 2 electrons in the outermost shell. All elements from group 3 have 3 electrons in the outermost shell. Okay, let us move to the next question. So this one also is coming from 2012 past paper, but this is paper 1. The previous question was coming from paper 3. This one is coming from paper 1. And the question is question 24. The diagram below represents the structure of a certain elementary particle P. Which of the following is not true about P? Okay. So we have 2 electrons in the first shell. We have 8 electrons in the second shell, and we can see -2 here, which indicates that this particle has gained 2 electrons. Which of the following is not true about P? A, P is an oxide ion. B, P is an isotope of magnesium. C, P has a noble gas electronic structure. D, P has 8 electrons in its nucleus. Okay, so our correct answer here is B. Why are we saying B? P is not an isotope of magnesium. So an isotope is an atom of the same element with the same proton number or atomic number, but different mass number or different neutron number. Okay, different neutron number. But we have seen that P is not an isotope of magnesium. P is an oxide ion. Yes, P is an oxide ion. Why are we saying P is an oxide ion? So we have seen that before this particle or before this element has gained 2 electrons, it had 8 electrons. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. So it is obvious that this element is oxygen and it is coming from group 6. So this one is an oxide ion. Let us also look at C. P has a noble gas electronic structure. So all elements from group 0 or group 8 has 8 electrons in the outermost shell. So we have also seen that this one has 8 electrons in the outermost shell. Let us also look at this one. P has 8 electrons in its nucleus. Yes, P. So we need to remember that protons are found in the nucleus, and the number of protons is equal to the number of electrons. So since we have 8 electrons here, 8 original electrons before adding these two. So since we have 8 electrons, this element also has 8 electrons in the nucleus. So therefore, our correct answer is B. We move to the next question. This one is coming from 2020 paper 2. And the question is question B7. Question B7, the question reads, atoms of elements A, B, and C have 8, 17, and 20 electrons respectively. B7A, using the letters, construct a chemical formula of a compound formed between atoms of elements A and C. Okay. So the first thing that we are going to do is to come up with the electronic configuration of A. So we have A, we have 2, 6. So we have 8. A has 6 electrons in the outermost shell. So for this reason, we are going to say A is coming from group 6. Let us also come up with electron configuration of C. C has 2 electrons in the outermost shell. So therefore, C is coming from group 2. Okay. So we have seen that here we have a metal and a non-metal. So therefore, the compound that will be formed is an ionic compound, since we have a non-metal and a metal. Okay. So all elements from group 2 have valence 2, and all elements from group 6 have valence 2. So we have valence 2 here. Okay, these two come here and these two come here. So 2 divided by 2, even here 2 divided by 2. Let me illustrate. So these 2 and these 2 cancel, these 2 and these 2 cancel. Then we are going to remain with the CA. Okay, we are going to remain with the CA. Going to remain with the CA. Going to remain with CA, as we can see. We are going to remain with the CA. So we have answered the first question. Let us move to the next question, which is question B. Elements B and C can react to form a compound. Name the type of bond formed in the compound. So B has 17 electrons. So if we come up with the electron configuration, B will have 7 electrons in the outermost shell. So therefore, B is coming from group 7. And it is obvious that B is a chlorine atom or chlorine element. So if we check from the periodic table, we are going to find that an element with 17 electrons is chlorine. Okay, so therefore we are going to say the type of bond that will be formed is the ionic bond. B. Roman numeral 2. State one physical property of this compound. So it has high melting and boiling point. It has high melting and boiling point. We move to question C. Draw the electronic structure of the product formed when atoms of element A combine. When atoms of element A combine. So element A, we have identified element A. So element A is coming from group 6. So element A is a nonmetal. So two nonmetals will form covalent compound. Two elements, two nonmetal will form covalent compound, also called a molecule. Okay, so A has 6 electrons in the outermost shell. So for this element to be stable, by the way, this is oxygen. So for this element to be stable, it needs to gain 2 electrons. So instead of gaining these 2 electrons, it will share these 2 electrons. This one also is supposed to gain 2 electrons for it to be stable. It has 6 electrons in the outermost shell, and it needs to gain 2 electrons for it to be stable. So instead of gaining these 2 electrons, it will share these 2 electrons. It will share 2 electrons. So this is an electronic structure of the product formed when atoms of element A combine. Question D. Give one industrial use of element B. Give one industrial use of element B. Okay. So element B, this is oxygen, and oxygen has a lot of uses. Oxygen has a lot of uses. Question B3. Atoms of J and K have 8 and 12 electrons respectively. B3. Determine the formula of the compound or molecule formed by the combination of J and K. Okay, so if we look at J has 8 electrons. So from the periodic table, an element with the 8 electrons is oxygen. Or if we come up with the electronic configuration, we are going to discover that J will have 6 electrons in the outermost shell. So therefore J, this is a nonmetal, and the K has 12 electrons. So if we come up with electronic configuration, K will have 2 electrons in the outermost shell. So therefore K is coming from group 2. Okay, K is coming from group 2, and J is coming from group 6. So this is the chemical formula or molecular formula. The chemical formula or molecular formula. And when 2 J's combine will form a molecule or covalent compound. So I'll give detailed knowledge about the covalent compound in the next video. For now, let us stick to ionic compounds or ionic bonding. Okay, so I have deliberately answered this one so that we continue. Okay, question B3b. In each of the cases shown in A, Roman numeral 1 and Roman numeral 2, name the type of chemical bond formed. So here the type of chemical bond is ionic bond. Here covalent bond. We move to the last part of this question, which is C. Give two physical properties of ionic compound formed in A, Romanium 1. So this one is a compound. This one is a compound. This one is an ionic compound. So this ionic compound has high melting point and it is capable of conducting electricity in a molten state. Okay, we move to the next question, which is question B6. Question B6, the following elements with their electronic configurations are in a given group of periodic table. In a given group of periodic table, we have W2, X2, 8, Y2, 8, 8, Z2, 8, 18, and 8. Okay. The next question, which is the first question, which is A. Name the group in which these elements belong. So, since their outermost shells are filled up, these elements are coming from group 0 or group 8. The next question, which is question B. What accounts for the chemical and reactivity of this group of elements? So their outermost shells are filled up or have 2 or more electrons. So therefore, 2 or 8 electrons, or they have a maximum number of shells per. They have maximum number of electrons in the outermost shells. So therefore, these elements are non-reactive. Okay, non-reactive. C. W is used in weather balloons. Explain why W is the most suitable for this use. So the reason why, by the way, W is helium. The reason why helium is used in a weather balloon, helium is less dense than air. Helium is less dense than air. So therefore, we are going to say W is less dense than air. D. Describe the change in density as you go down the group. So as you go down the group, density increases. As you go down the group, density increases. Okay, density increases. We move to the next question. So this question is coming from 2022 paper 2, section A. Section A. The following dot and cross diagram represents a compound. Identify the compound shown in the diagram. The compound is, so since this one is losing 2 electrons, this one is coming from group 2. And since this one is gaining 2 electrons, this one is coming from group 6. Okay. So let us consider A, magnesium chloride. By the way, magnesium chlorine is coming from group 7. So A is not our correct answer. Let us look at B. Let us look at C. Sodium is coming from group 1. Sodium is coming from group 1. Sodium, C is not our correct answer. D, we have sodium. Our correct answer is magnesium oxide. So magnesium is coming from group 2 and oxygen is coming from group 6. So our correct answer here is B. By the way, you are free to pause the video and try to come up with the original electronic configuration of these two elements. So our correct answer is B. Okay, our correct answer is B. The last question is coming from 2024 paper 2 GCE, and the question is question B3. The following diagram shows electronic configuration of ion of element M. A, Romanium 1, Draw an atomic structure and write the electronic configuration of neutral atom of M. Atomic structure, the atomic structure. So we have nucleus surrounded by. So this one has gained 2 electrons and it has 8 electrons in the outermost shell. So to write the original element, we are going to remove 2 electrons. We are going to remove 2 electrons. By the way, we are told that this one is an ion. So we are going to remove 2 electrons. We remove 2 electrons. We are going to have 6 electrons in the outermost shell. 6 electrons in the outermost shell. The next question, we are also told to come up with electronic configuration. So to come up with electronic configuration, we are going to say 2286. So we have answered this question. Let us move to the next question. We move to the next question, which is question A, Roman numeral 2. Give the name, group, and period of element A. So the name of the element. So this element, according to our periodic table, is sulfur. This is sulfur. This is sulfur. You are free to pause the video and check your periodic table. Okay, and this one is coming from group 6 and the period is period 3. The last question, which is question B, compare the reactivity of an atom of M and an ion of M. So an ion of M, let me come back here. So we have seen that an ion of M has 8 electrons in the outermost shell. So therefore this one is stable. This one has 6 electrons, as we can see. This one has 6 electrons in the outermost shell. So the one with the 6 electrons in the outermost shell will be more reactive than the one with the 8 electrons in the outermost shell. So therefore we are going to say M is more reactive than ion of M because its outermost shell is not completely filled up. Okay, its outermost shell is not completely filled up. So ladies and gentlemen, this brings us to the end of this